So let's talk about your first programming assignment. And you can ignore the due date on it. It's old. We'll set the due date here. So get into the Blackboard shell. And scroll down, you see a folder that says Programming Assignments. So we're going to do Program 1, Cube and Sphere. So there's a PDF file that has some instructions there. So go ahead and look at that. Obviously, that's not the right due date or year. It's not even the right course number anymore because we've changed that. So anyway, we're going to make this do let's shoot for the 20th, which is next Thursday. And we'll see how we're doing. If you need more time, I could probably let you go to the next Tuesday after that, but let's try to get it done by the 20th. This is going to be very similar to the program that we did, the circle program, but it's not exactly the same. So don't expect to just copy and paste everything and have it work right. Okay. So let's look at this. So it says write a complete C++ program that will ask the user to enter in the length of the side of a cube. Okay, so we're not entering the radius of a circle here. We're entering the side of a cube. Okay, so one thing we know is all the sides of a cube are equal, right? So all three sides are equal in length. Based on the value that's entered by the user from the keyboard, calculate each of the following and assign your results to variables. Okay, so you need to determine the largest. The radius of the largest sphere that would fit in the cube. Okay, so if you want to visualize this, let's see here. You can visualize it like that. So suppose you had like a ball. You could picture it like this. So you got a box, right? A cube box, and you've got a ball or sphere that fits into that box perfectly. So that the sides of the ball touch the sides of the box, right? But it doesn't like bulge it out or anything like that. Okay. So in other words, what you know is that the length of the side of the box is the same as the diameter of the sphere. Okay. So things that you have to calculate, the radius of the largest sphere that would fit in the cube, right? So that's going to be half the length of the side, of the cube side. Okay? And I have some formulas down there to help guide you. But again, you can't just type these formulas in there like that. You have to use the C++ operators, like the asterisk for multiplication and stuff like that, and the power function to raise the base to an exponent. So the radius of the largest sphere that would fit in the cube, the volume of the cube, which is it's length times width times height, right? For any kind of rectangular prism, but a cube, all those are equal. So all you have to do is side times side times side, or side to the third power. That gives you the volume of the cube. The surface area of the cube is side squared. That gives you one side area, right? But then you've got 6 sides. So 6 times side squared will be the surface area of the cube. In other words, if you were to wrap this up in wrapping paper or whatever, and you had the perfect amount of wrapping paper, where you didn't have anything left over or anything like that, that's how you could calculate that. The volume of the sphere, we've already done that, right? 4/3 pi r cubed. Watch out for integer division on that. So you want to do 4.0 divided by 3.0. Surface area of the sphere, we've done that before already. 4 times pi times radius squared, right? And then how about this one? The volume between. The volume of space in between the cube and the sphere. So in other words, if you were to fill this thing up with water, how much water would be required, or how much, what would the volume of that be? Okay? And so you can calculate that. That's not that hard because you've already calculated the volume of the cube at that point and the volume of the sphere. So just subtract the volume of the sphere from the volume of the cube, and that'll give you the volume between. Okay. So the format's going to be very similar to the example program that we did, right? You're going to need that same constant for pi. You're going to have some input from the keyboard, but instead of inputting the radius, you're going to input the cube side, right? And then you're going to have some calculations, assignment statements, and then you're going to output your results after that. So, and your output should look something like this, except just like with the example that we did, your text is going to be left aligned and your numbers are going to be right aligned. They're going to be over to the right a little bit. You're going to have space in between the text and the numbers. Okay, so don't let that throw you on there. All right. Other things to mention: you need to have a block of comments at the top that has some information like your name, course, compiler, and a brief description of what the program does. You can comment other things in there as well. Like I like to comment sections, and so that's what we did in the example together. Use descriptive identifier names. Don't just use like R and S or whatever. Name them things like side or radius or sphere radius or whatever. Use constant for pi. Use doubles for your data types, so you'll get an accurate decimal answer. Output to the screen to 3 decimal places. So again, left align your text, right align your numbers. All right, what do you think? It's very similar to what we just did, right? All right, good deal.